Well, let's go back a bit. So, real quickly, why don't each of you just introduce yourself and your job title, and then what we'll do is we'll have each person talk a little bit about their company.
Sure.
So let's start with you, Tyler.
Okay.
Yeah.
I'm Tyler Wolfe, Director of Solution Architecture at Framebridge. We are essentially the online e-commerce solution to the custom picture framing industry. So we take hundreds of thousands of art pieces, posters, purple hearts, anything ranging down to quills for the Library of Congress, and turn them into finished wall decor pieces.
Okay.
Yeah. I'm Joe Lau, Product Marketing Director for Fetch Robotics. And what we do is develop and manufacture autonomous mobile robot solutions for warehousing and manufacturing. Our solution is really made up of two key components. We've got a broad range of turnkey autonomous mobile robots, and we also have our Fetch Core suite of software and services. And so our cloud robotics platform is our commercial solution. Essentially, what that delivers is what we call on-demand automation. It's the ability to deploy or redeploy very quickly on your own, the ability to start at a relatively small scale and scale really up and down quite quickly, and the ability to really automate any sort of movement or workflow. And actually, if you flip over to the next slide, that'll give a little bit more reference. But it essentially allows you to automate any sort of workflow, and that platform-based approach that we've got is really the key enabler for this technology to really extending beyond fulfillment type workflows.
Okay. And well, why don't we do you, Bruce? Go ahead.
Yeah, hi, my name is Bruce Welty, and right now I'm the CEO of Quiet Logistics, which is a fulfillment company, mostly high-end apparel and premium branded products. And prior to that, I was the founder and CEO of a company called Locus Robotics. And prior to that, I was the CEO of and Chairman of Quiet Logistics, so kind of a full circle thing. And we built a robot because we were users of Kiva, which is a robot that works in warehouses and does fulfillment. And Amazon acquired that company in 2012 and took the product off the market and renamed the company Amazon Robotics. So we decided to build our own robot, and we did that, and we split the companies, and now I'm back at the original company. So we actually have one of our customers here, or Locus's customers, which is now one of my competitors, Geodis. So we're all one big happy family up here.
And Alan, it's up to you now.
All right, I'm Alan McDonald. Oh, sorry.
Yeah.
Is that better? Now I don't have to yell, I guess. Alan McDonald, I'm the Senior Director of Continuous Improvement for Geodis. I'm also responsible for innovation in the Americas for Geodis. Geodis is a global transportation and logistics company. You can see the description up there, but we've got presence in 67 countries. We're headquartered in Paris. Our Americas headquarters is in just south of Nashville, Tennessee. But really the reason I'm up here is we partnered with Locus at the time, but we were trying to find a solution. As everyone probably knows, unemployment is so low right now, it's a challenge to find labor. So that was really the reason that we started looking for a solution like this.
Okay, great. So the next question is for users. And Bruce, you're sort of this weird hybrid guy that's part user and part supplier. But I'd like both Tyler and Alan, and also you, Bruce, to sort of say, what was the context that sort of drove you toward this? And it sounds like for you, Alan, it was mostly labor shortage, right?
It was. That was what started it. Obviously, the more challenging it gets to find labor, the more expensive that labor gets as well in the market. But in addition to that, our workforce is more and more international. We have a large percentage of our workforce that is not English speaking. So we were really trying to find a way to make the job more fun and enjoyable for them. It became not only trying to make our current workforce more productive, but also make the job more enjoyable so that we could retain that workforce as well.
Okay. And do you have any statistics around, for example, if you went back 10 years ago, how many applicants would there be for each warehouse job? Today, how many applicants? Any sort of statistics sort of around the labor issues you might have?
I don't have any actual numbers, but I can tell you it was much easier to find labor 10 years ago. It was not a problem. If we were ramping for peak, we could have a job fair and we could fill every role. Now, we cannot fill every role. And even at times, people will accept the position and then they won't, they'll find another position across the street. It's just hyper competitive.
Right. And wages, how much have they gone up in the last year or so?
Significantly. It really is a hockey stick. It's not a linear function right now. It's more exponential.
Right. And Bruce, I think I remember Quiet Logistics. For you, robotics was a business model for Quiet Logistics, wasn't it?
Yeah, so we've been trying to solve this I would call it pick problem forever. I'm in my 31st year of trying to solve it. And if you think about sort of what happened in the last 20 years, we've seen e-commerce go from being sort of smaller than the smallest store to bigger than the biggest store for most retailers. And so the pick problem got bigger. And back in the late 90s, we were innovating in the world of software using warehouse management systems and radio frequency control devices. And we started to just see this enormous challenge for these clients when they started taking these boxes apart and opening them up and trying to move things around the warehouse in units, or we call them eaches, as opposed to cases and pallets, because the whole supply chain really was optimized for cases and pallets. So we sort of reached the limit of our ability to do that with the technology that was out there. And Kiva came along in the early 2000s and had this cool innovation where you could almost treat all your inventory like a vending machine. And everything was stored, literally on an XY coordinate in a pod. And you wanted any product, you could push a button and that pod would come to you, and then you could pick the item off that pod, and then the pod would get returned back to the XY spot on the floor. So we thought that was pretty cool, and we thought we could really make our lives as operators a lot easier if we just built our whole business around this concept, because then we'd never really have to worry too much about inventory control and availability, and it just made our lives a lot easier. Amazon came to visit us one day and they agreed, and then they bought the company that made the robots. And we're still thanking them for that. But we then decided, well, maybe there's one more level of innovation here where we can take these autonomous mobile robots, which in that 10-year period after Kiva was invented, the robotic world had changed quite a lot. People had invented all sorts of open source software and released it to the wild, and sensors had improved and prices had come down. And we were just much more able to work with new tools at that time. There were many more people that understood how robots worked. So when we got into it, we decided to take another, even we think better approach to what Kiva did. And Fetch, was doing the same thing at the same time. They came to the same conclusions we did. So now we've taken it to the next level. And our approach is that, you really cannot do this anymore without robots, because people are too expensive. And, with our logistics company, I'll give you a statistic. We hired 1,303 people to fill 316 positions. So that tells you how many people didn't show up for work or dropped out within a couple of days. That was for this year's peak. So when just think about the cost of training nearly 1,000 people that didn't even show up for work or didn't stick around. So those costs really, really hurt the service provider. And we're focused right now on trying to make the jobs better. Just like Alan said, the robots speak different languages. And, we're seeing big improvements in productivity. So everybody wants to know how many jobs are you eliminating? And my answer is, well, I don't think we're eliminating any jobs, at least not in our world, because we can't find any people to do the jobs.
And Tyler, what was the context, what was the driver for Framebridge doing this?
Yeah, so our primary challenge of our business is really just an extension of our growth. So at this point, we've been doing right around the ballpark of doubling every year since the business was started. And it's a pretty operational intensive business. We make every product, so we have fabrication that is involved with making components and receiving artwork from upstream customers and turning that into a finished good. And so it is operationally intensive. It's doubling every year. We don't today have a good process for, unlike in some more perhaps traditional fulfillment, where we can lean on third-party logistics providers to assist us during our peak seasons. And so we were essentially looking for a way to, how do we make the workforce that we have more productive? How do we keep people who are providing a lot of value in the product, where we have to invest significantly in cross-training for machine operators and a lot of specialty art and mounting processes. And so our goal was to determine a way to where we can keep people in their workstations, keep them productive, and avoid scenarios to where 30% of someone's day is doing indirect tasks. So productivity, enhancing the productivity of the existing workforce was our primary driver.
Yeah, and it sounds like there's so much, when you hear about autonomous mobile robots, what you hear about over and over is e-commerce picking, but that's not what's driving you.
Yeah. So,
Yeah.
for us, we have a sequential process that involves doing many different things to finally get to a finished product. And so we have components and then sub-assembled mounted artwork that has to then become framed artwork that has to be then packaged. And so essentially what we wound up with over time were hundreds of manual push carts going between different work cells and work zones. And so our objective was, how can we use some type of solution outside of conveyors, because we don't have a sortable or conveyable product. So things like glass and artwork, you just wouldn't put them on a conveyor belt and send them down the line, or use a tilt sorter or anything like that. And so instead we had push carts, and we have a bunch of our team members who are spending a significant portion of their day just pushing carts from A to B and then B to C and C to D. And so obviously over time we are losing more and more of our both of our warehouses' capacities to those indirect tasks.
Yeah. The next question, I'm going to start with you, Joe. But if you look at material handling, there is something that is called automatic guided vehicles that would fall little tags on the floor, and they would go from point A to point B, like in Framebridge's operation, and they'd deliver something and then they'd go back, right? And there are still some autonomous mobile robots that do that. The difference is that they're not following markers on the floor. And if there's an obstruction, they can go around it. And maybe they even go around it by going down an aisle and coming back down a different one. So they're more flexible, they're easier to set up, but there's not really a layer of optimization logic. And then there's autonomous mobile robots that have optimization. So Joe, if you wouldn't mind, for your company, would you talk about how you approach optimization and how that works with the process?
Yeah, I think there are a lot of ways nowadays to, govern the movement of the robots. And so I think the key differentiator between an autonomous mobile robot and an automated guided vehicle is the AMR's ability to replan, and not just to stop if there's an obstacle in front of it, but to figure out how to get to point B any way that it can safely. And so, for something that like something similar to what we provide, we actually have a lot of ways of doing that. You can actually set it up to perform just like an AGV and be very rigid around how it's going to get to point B. You could set up preferred paths where you prefer the AMRs to travel down a path, but if there is an obstruction, it'll maybe wait there a little bit for that obstruction to clear out, or it'll move around it, figure out another way to get there. You can have it move completely or calculate completely independently how to get to point B, or you could have the system itself sort of govern that movement. And so there are a number of different ways, at least from our perspective, that we provide that level of instruction. In terms of the obstacle avoidance, one of the interesting things for me, at least, that I see is I'll head out to a ProMat or a Modex, and the last few years, my sense is that everyone throws a sensor on anything that's moving, and they put a stamp on it. It's got obstacle avoidance, and that's just not the case. It's not a trivial task to avoid obstacles, and so there's a fair amount of software that we build into our systems to ensure that the AMRs are not only capable of avoiding stationary objects, but also dynamic obstacles, things that are moving, being able to judge direction of travel and speed of travel of things that are not robots, and then being able to properly deal with that type of potential collision, if you will. So, in the case of Tyler and Framebridge, just I think the constraints around your particular environment. It was an odd environment where potentially, an AGV was maybe not an option, right? So, yeah.
Yeah. I think there are certain operations to where they're laid out potentially with AGV tracks in mind.
Yeah.
They're built that way, or they're retrofitted that way. And with our operation, to handle our growth without growing our building, within our financial plan, we're essentially maxing out for space. And so there are many of our paths and flows to where it wouldn't have been an option to carve out dedicated space for some type of material handling traveler. And today, several of the places to where the Fetch robots are traveling, hundreds of employees travel down that path as well throughout the shift. And so we needed to be certain that the robot was friendly to that level of pedestrian traffic. Certainly.
So Bruce, Bruce and I actually have known each other for a long time. Bruce actually used to, before he started these other two companies, he started a warehouse management system company, a software company. And WMS is, like you said, it has optimization around, you sort of batch up these orders. And by batching orders for a carton, picking cartons or picking pallets, you could have less travel through the warehouse. But at Locus Robotics, you also have optimization in efficient movement through the warehouse of your robots and people, correct?
We do. We had actually a really big project with one of the Geodis customers around optimization. And to describe the problem, I'll use an analogy that I think it makes sense to people. If you think about fishing competition, and the objective is to go out, send out however many people want into a lake and catch as many fish as they can, and they all come back. And the guy who catches the biggest fish or the most fish wins the tournament. And one of the problems with that is that nobody knows where the fish are. And so you have a lot of people, and they come back and they don't catch very many fish. compared to how many fish are in the lake. But with our system, if you think about it, we know where the fish are, which in our case is a pick. So we look across this huge area, and we call it a field, and we'll see that there are picks distributed around. There's a certain regularity to it. There's some clustering based on hot products and so on, but in general, there's clusters of work, and it changes all the time as people's buying patterns change. But what we're able to do with our robots is concentrate the robots where the work is, and then also concentrate the orders together. So if the robot is going to go out to perform a certain route, or we call it a mission, we'll try to make sure that that mission is as short as possible by clustering orders together that have picks in similar places. And so what you end up with is effectively taking this lake of fish, and you kind of drain it down so all the fish are in just a corner. And that way you can actually have one guy catching many more fish than, in fact, all of the fishermen fishing together. So we create these abilities to concentrate the work, the robots, the work, and the people in the same place. And then we move it around the facility. And maybe I'll tee it up for you, Alan, because you guys saw the power of this algorithm. And in fact, we then had to do something quite interesting.
Yeah, so I think there are 2 points that you kind of set up there. So what Bruce was talking about was basically you see a wave effect across the facility whenever they use this optimization. And if you do a time lapse of the picks, you can actually see the picks go across the facility, and they wave. It makes each operator much more productive because the Locus knows where the next set of work is. They know where the operators are, so they can match those two. The second point I'll say, though, is you can optimize that almost definitely to a fault, right? To use Bruce's example, you could send all the boats to exactly the same cove, and then they all get in there and no one can move around. So they also optimize to the point that if there are too many bots in a specific area, in an aisle, they won't send the next bot in there. They'll wait until it cleans out so that you don't have the bots just getting congregated all together and all your operators in one aisle. So there are a couple different points that's set up, but it definitely, you can absolutely see the effect of their optimization and how the work moves across the facility. In our first building, it was 66,000 square feet. So you could see the picks just wave across multiple times a day.
And let me just, I want to be able to have the audience visualize this a little bit. The Locus robots move to a shelf where a pick is going to be, and then the person sees the robot sitting there, and he goes and he grabs something out of the shelf and he scans it and he puts it on the robot. And when the robot has enough cartons, enough bins filled, it goes to a pack station. Is that right?
Right.
Yeah.
So
Go ahead.
We are right now
Yeah.
in the facilities. We are discrete order picking. So there are a set number of orders on each bot, and we'll have a tote configured so that the orders are kept separated. So it will go out. Locus actually builds which orders are on a bot. So they optimize it that way. But then once the work is completed, they will send it back to packing. But yes, it goes out. Actually, when an operator is done, it will direct them to the next nearest bot. So it tells them where the nearby bots are as well.
Okay. And Joe, we've been talking about Fetch Robotics in terms of paths and obstacle avoidance, but you guys also do each picking, right? Do you have any sort of optimization logic around the picking?
So for us, we've basically got a number of different recommended processes based off of the different types of solutions that we have to offer there. And so it's a little bit of a different approach. And if you're looking at, something like an each pick, we've essentially got two different solutions: an HMI shelf, which with an integrated touch screen, but we also have our Cart Connect solution. And so, essentially what it is, it's just a regular warehouse utility cart that a warehouse associate could use, and at the same time, the robot can engage with a cart. And so, we're not super religious about the number of robots that we necessarily sell. It's really more about the utility and the collaboration with an existing workforce in their process. And so, in some cases, it may just be 6 robots, but it may be 30 utility carts. And, the robots are in constant motion at that point, and you've got this collaboration of the workforce with the robotic solution.
So help me visualize it. So, a picker would be filling up a cart in a row, and when he's done with that row and the cart is full, he leaves it at the end of the aisle, and the robot comes and grabs the cart and takes it to the pack station.
Yeah. So that would be a fairly typical setup where, you would either have some sort of call button, or you would have some sort of scan that would trigger, the robot for the pickup. And so, there are a number of different ways of doing it, but we have a few that tend to be sort of rinse and repeat type processes. And so that tends to be sort of a phase 1 approach, if you will, of being able to do this outside of really any sort of integration, which is kind of nice. You get started up relatively quickly. And then, for us, again, there's no religion around it, but if you want to do that level of system integration, we offer up a package to be able to do that. Or, we tend to think of it as more of a phase 2 to what we're bringing to the table.
So let's move to some questions for the users. And let's focus on the implementation. And maybe we'll start with you, Alan. Geodis is one of the biggest 3PLs in the world. Can you sort of walk me through, was this a proof of concept, and then it was an implementation, and you're testing out other AMR providers, and sort of walk me through the beginning, past the proof of concept, past pilot, to the actual implementation.
Okay. We knew we needed to solve a problem, and so we started looking. We honed in on AMRs, I'd say, pretty quickly. There are several providers. We talked to several of those, and really, there were a variety of different components we looked at. Some of it was culture with us. Some of it was just the confidence we had in the solution. But we decided on Locus, and then at that point, it came down to finding where we wanted to run this pilot. So we decided we were going to run a pilot. We had set our pilot up for 90 days. Take your pick there, but we wanted to make sure we could see the results. So set it up for a 90-day pilot. I think we had to do the interface for the first one, obviously, for the pilot. So we established an interface with our WMS. It was our homegrown, our legacy WMS, and ran that pilot. We saw the results, and at the end of the pilot, just ran it into that ongoing operation. They stayed there. And then at that point, we started rolling it into other operations. So we've done 2 other operations now. We actually just signed, the ink still might be wet on it. We signed another one just in the last 24 hours. So, but now it's less of an innovation project since we've seen the results, and it is more of that's another technology. It's another arrow in our quiver, right? So if the profile matches, and we will go to Locus and we'll ask them, does this match? But we've done implementations as quickly as, I'll let you correct me if I'm wrong, I think it was 35 days, something like that. That was quick. but that was a successful implementation. I wouldn't do every one that quickly, but yeah, it's just become another piece of technology that we have now. It could be a conveyor sorter, but that's another.
So the tough part is integration to your existing WMS. Is that the biggest step that slows you down?
It's not a complex integration, but that is, historically I've seen that sometimes when you go to IT people with a request, they can push back. So I know, right? Maybe it's just me. But it's not a complex integration. What you do, you want to make sure you're covering as many use cases as you can. But that was the long pole in the tent. After we decided on our partner, that was the long pole in the tent, was getting that done. And it was really more on our side than it was on theirs.
Okay. And Tyler, would you mind walking me through the whole implementation process at Framebridge?
Yeah. So, yep.
Yep.
So for us, I think we determined that mobility, specifically with the fact that we prefer a vertical presentation of our components, we have some specific methods to keep what are relatively fragile goods moving throughout our facilities safely. And so we began essentially surveying what solutions were out there that would fit the profile. So we don't use traditional tote bins that go on conveyors. We don't pick into tote bins. We use essentially what would look more like magazine racks, because all of our product is essentially very thin, very tall profile, standing upright. And we did start with limitation related to integration, is that we would have to be able to demonstrate value and work through the pilot without some type of robust integration. And that was mostly just because of the bandwidth from our current engineering roadmap. My engineering team didn't have any additional bandwidth to throw at an integration to get through some type of proof of concept. So we were looking for something that had I would say, ready to go or a turnkey type of benefit, so that we could circle back around and look at a more integration, deeper solution down the road. So as we began sorting through those things, we certainly looked at a lot of AGV vendors, and we had some of those folks on site, and we did some demos related to obstacle avoidance. We actually had a vendor come and do a demo, and their AGVs actually crashed into each other, which was of course disappointing. But yeah, we certainly won't name them. So with Fetch, we felt like the combination of it being definitely having turnkey working out of the box elements, as well as the fact that in our business, we understand that how our facility is configured today won't be how it's configured in a couple years. And it is very likely that we will both relocate our warehouses and also add additional warehouses. And so we wanted something that is very flexible and where we could move origin and destination points, we could move pick paths, we could move, we're also using the tag surveyor, which is a pretty unique application. And so we were actually working on RFID before we started looking at AGVs. And so finding a vendor in Fetch that could actually help us work towards solving both of those problems in unison was a big value add for us. And so we did a pilot, and the pilot was for 90 days, essentially for us to just ensure that the technology, both hardware and the Fetch Core software, did what it said it would do, and that we could prove value very quickly within those 90 days. And then at the end of the 90 days, internally we agreed that was the case, that the Cart Connect solution to move physical goods within our facilities, and then also the tag surveyor to track RFID tagged items for us as artwork, and high value artwork in particular. Both of those things checked all the boxes that we were looking for. And then post the pilot, we essentially bought out all the equipment from the pilot. And then currently we're working on a roadmap to how do we essentially expand both the hardware, the number of robots, and then the number of applications that we're using those robots throughout the operation. So our personal thought is at this point, we're kind of just scratching the surface of where what we can do, but we are certainly, in the post-pilot beginnings of a full-scale, long-term implementation.
So I've got a couple follow-ups here. So first of all, once you made the decision that Fetch Robotics was going to be your company, for that, how long did it get those first robots working? Was that a month? Was it a week?
Yeah, so I think for us, it was a relatively quick process. So I think how Fetch structures their pilots is helpful. It can essentially be done either the CapEx, obviously you would know better than I would, CapEx first, or a combination of OpEx and CapEx. And so obviously CapEx is always relevant, both for me on the engineering team and then also a lot of the hardware equipment that we buy. That's always a tricky discussion with our leadership teams. And so through their model, we were able to essentially get in within, I want to say 30, 40 days of having robots on our floors without any capital investment in order to work through the proof of concept. So once we were confident that Fetch is who made sense to work with, our sales contact there was able to work with his team and within a month and a half have us robots to begin piloting and trialing through different tasks and essentially learn how to work with the robots.
You mentioned RFID, and the way I was reading that is the robots are reading RFID tagged inventory. So it's a cycle counting application, or how would you describe that?
Yeah, so I think in a lot of customer use cases, it is traditional cycle counting of finished good inventory, pallets and cases and finished goods.
Right.
For us, it is that we are processing every day inbound hundreds of pieces of artwork. So some of those artworks are replicable. They're a vendor who sells a print, Crate and Barrel, somebody like that, and they can produce thousands of that. There are a whole swath, at least half of the artwork we touch every day is not immediately replaceable. So it is a single original piece. And so we have historically used systemic processes to track those via states and statuses to say this is here in our process. And so therefore physically we believe it to be here, but we never knew, exactly tell me where this piece of art is, especially we deal with some things that are worth several $1,000s. And so there are definitely points to where a status is wrong or a state is missed by an operator. And we want to know, very granularly, tell me exactly where in the facility this is right now. We didn't have a solution for that. We looked at RFID via mounted readers. The trouble with mounted readers is that they're more zoned. They essentially use, generally, the solutions we were looking at provided more zones of areas. And so that wasn't really what we were looking for. We wanted a more specific, give me an XYZ coordinate of where this item is. And so since Fetch tag surveyor is moving, it's able to triangulate the location of the RFID tag and give you a very precise location of it's on this cart, on even the top portion of this cart in this bin, which provides a lot of value to us. So it is cycle counting those RFID tags. It's just not finished goods for us. It's more of a work in process, high velocity inventory.
Right. So is there, so the way cycle counting would usually be done, there'd be a WMS system, and it would say, in this location, we expect there to be this many items, right? And you would go and you would check and see if there were that many items there, right? And if there weren't, you'd want to find out where they are, and it's often hard and manual. In your case, is that what it is? Is you've got a system that says this is where it should be, and the RFID cart goes through and says, well, it's not there. Or is it just we're finding every RFID tag and creating a new map all the time?
Yeah, so I think we use it more for the latter approach.
Right.
So since we have more sequential processes, we have this art process and then potentially a cart, a push cart or a pick cart, and then another process. And we also have many different components that belong to the same order that have to be assembled together. We're very interested in keeping a dynamic map of essentially where is everything and how is that flowing throughout our operations. And then also if I need to then drill in and say, where is a specific thing or where are a specific number of types of items and how long have they sit in that specific location. They haven't moved at all. And then also the area that they're in. So you can do both very specific coordinate location and then also areas and zones. So we use it more as the holistic mapping and instead of location by location cycle counting.
Okay. Alan, you had this great new technology. You're going to implement it. Any sort of people issues around this, or if there were, how did you address them? You know?
The first thing I can tell you when you walk
Yeah.
in, and I make sure I go in and present every time we implement these, I present it to the operators. And with the first operation, it took about 5 minutes for somebody to ask me, are these things going to take my job? Fortunately, that's an easy answer. I mean, the reality is we cannot find enough people. So no, it's not. It still requires an operator right now to pick to it. So that's a pretty easy answer for me. The reality is once the employees get used to operating with these things, it's an iPad interface on Locuses, for example. It's an iPad interface. The percentage of the population that has not operated an iPad is probably growing smaller. But it's very easy. It shows them a picture of the item. They actually love picking to these things. So it became a very easy sell for us. And in fact, now when I'm going to put them in another operation, I take someone that's picked to them, and I take them and I let them participate because people love picking to these things. Even after the newness, there's always a newness factor with this technology, but even after that wears off, people really prefer picking to these than a standard RF gun.
Right. And when you have a brand new employee, do they train faster on this? Do you have any statistics around that?
We've cut our training time in half, and even that's probably conservative.
Yeah.
In fact, it almost works to our detriment because the key metric we measure is units per hour picked for the bots or for the operators to the bots. But what ends up happening is the operations team will bring in their newest employees. They automatically put them on the bots because it's such a short training time, and they put their more experienced folks somewhere else. You don't get as much of the benefit of people getting used to it to build that critical mass. But yeah, it is cut our training time in half for new operators.
Right. In picked cart warehouses, I've heard sometimes people walk as much as 10 miles a day. Do you have any measures of how much less people are walking? And
I don't know the exact amount. I know two things. They are walking less because of the optimization. Also, it's an easier walk. They're not pushing the cart. Sometimes in an apparel operation, those carts can weigh 250 pounds potentially, depending on how big it is. But they're not pushing a cart. They're not carrying and having to hold that RF gun with them. They see on the previous bot where they need to go, and they walk to that spot. So it's a much more enjoyable walk. Not only are they walking less, but it's a lighter walk.
Right. And Alan, how about for you? Not Alan, Tyler. Any people issues implementing this at Framebridge?
So I think initially there was some, so we have some more industrial equipment in our operations. We have large, gantry cutters, industrial saw lines, and things where we have equipment that is essentially taken very seriously from an operator standpoint, from a behavioral standpoint, and then also from disciplinary in terms of operator behaviors. And so initially when the robots were driving around, you had some of that same leeriness around industrial equipment, particularly, the initial thing, I think, especially because these are driving down primary pedestrian travel paths, is this thing going to run into me? Do I need to stay well out of its way? So you had a lot of those types of obstacles, but really within a few weeks, people are just getting used to this thing isn't going to run into me, particularly with a tag surveyor, which is traveling in very, all over the place throughout the facility. It just becomes accepted as a known thing that the tag surveyor, essentially people just don't have to pay much attention to it. They don't have to stay out of its way or treat it any different than any other person or, a picker going down the aisle. And with the car connects, their ability to dynamically move out of the way of, a parked forklift or pallets dropped in the wrong location or a line of 100 people clocking out for a break, has made it such that, essentially people can get used to the fact that they don't have to, treat them differently or don't have to be leery of them. But I think there is that initial concern of, essentially, is this thing going to run over me?
Right. I want to move to benefits now, and I think a couple slides have been provided. This is a Geodis slide. So we've talked a little bit about the training benefits, but maybe you could walk me through some of the other benefits here.
Yeah, sure. Late last year, we had 175 bots in operation across 3 operations. I've got 3+ on there because I knew we were about to sign the 4th one.
Yeah.
But really have seen double our productivity. And that wasn't a one-time event. That was during our pilot, we doubled our productivity, and we've maintained that. The other operations, we have hit double our productivity. We're still, I tell people all the time, it's very easy to learn to pick to these bots. Managing them, it takes a little bit to understand how to manage them. So as our operations teams come up to speed, we are 100% confident we're going to exceed 2x productivity.
So picks per hour before, picks per hour after. Can you just give me approximate numbers there?
In our pilot operation, we went from 65 units per hour,
Yeah.
so not lines, units, but 65 units per hour to 140.
Wow, that's great. And I can't remember, Tyler, did you provide a slide on, here's a slide. Can you talk through your benefits?
Yeah, so I would say for us, we would still, in terms of hardware, we were at a relatively early in the stages of implementation. So I think we're just scratching the surface in terms of benefits realized. In the workflows that we have essentially made through the pilot and are running on the Car Connect, we have seen the indirect time be able to be reduced by 70%. Which is significant for us, significant for anyone, but in particular for the workflows we put it in. We're essentially taking processes to where an operator is a quality control for high-value artwork line. So they're inspecting the finished product. That's a very important critical task for us. The reverse logistics costs of any essentially order failures, it's a very expensive process for us to get something back. And so for that person to not spend half of their day walking a push cart to a downstream process and packing and shipping, and to be able to inspect more items per hour. So we have several flows that are like that, to where it's a very value-added operator that we're able to keep in their work cell. That indirect time is critical for us. And then for the tag surveyor, we have cases to where we have essentially inventory or artwork get out of location. Either picked to the wrong cart or the cart was delivered to the wrong cell. And sometimes those are only for short periods of time, but we have very tight, like a lot of fulfillment operations, SLAs. And so there are very real costs in terms of SLA failures, replacement carts. We may replace artwork that is temporarily out of location or double fulfill an item because of errors like that. So having the tag surveyor ensure that we can know where artwork is, we're not losing artwork, we're not temporarily having artwork out of location, has real tangible benefits when you're talking about, some of these print pieces are worth, hundreds or thousands of dollars. So both of those we feel like we're realizing them probably at the small scale micro level today, but we want to apply those same flow benefits and then just get, many more flows. Instead of 3 flows, make that 40 flows. But we're certainly seeing those indirect and inventory benefits.
Are you able to put a payback number on it? Payback less than a year or payback in a year and a half?
Yeah. So On the so the tag surveyor has a particular task for us. It was something that was essentially we weren't replacing labor in that scenario because we didn't have a solution to do it.
Yeah.
But in terms of the opportunity cost of SLA failures, replaced artwork, replacement of goods, there's certainly a payback of less than a year. On the cart connects, it is more 3 to 6 months
Wow.
in our ballpark. It's just very straightforward. We had a lot of walking and a lot of indirect labor, and so it's very straightforward benefit because it's labor we're paying for today.
Right.
That can be avoided, and we can keep people doing value-added tasks since most of the people pushing carts weren't pickers in a traditional fulfillment environment. They were workers who were essentially just moving the product down the line via a pick cart.
Yeah. And for you, Alan, do you have a payback period on this investment?
We've seen similar numbers. I would say I've seen ranges from the 6 to 9 month to I think one of them was 18 months.
Right.
Which wow.
Yeah.
When that's your worst case, that's still pretty good. And it really Locus has been flexible with how they structure the contract and things like that that enables that. So, but yeah, absolutely.
Right. And historically, my gut is companies sort of balk if payback period is over 2 years, and there's a lot of technologies that are sort of right at that 2-year period. Is that sort of your gut around this as well?
Yeah, it definitely is. When it starts getting up over 24 months, people really start asking questions. So.
Yeah. So for both Alan and Tyler, whoever wants to go first, fine. But you've been through this. It worked. But you're smarter than you used to be. Is there anything you would do different? Any advice you'd give to folks out here in the audience that might want to think about this?
Go ahead, Tyler. You want to go first?
Yeah. I think probably on our part, me personally, my team, some of us are technology first, both from our roles and then also just our point of view within the organization. And so I think better engaging early on with, operations managers, the operation team in general, is helpful, especially because I think, like Alan discussed, the people element of the teams that have to use. Obviously, on the technology side, whether it's software or in this case a combination of software and hardware, there's maybe an assumption that if you build it, they will come, or if you give a really great tool, that it will be used how you expected. And so I think engaging with the operations team to make sure that they're helping with the planning of the workflows and how best something like this can be utilized is critical if the initiative is going to be led by somebody outside of the traditional operations management team.
Okay.
I would agree. Fortunately, I guess, as we have enough size and different operations that I get to learn from my mistakes because we are rolling this out to new operations successively. So, but I would say really the thing that we tend to focus on going forward, we looked at the flexibility. We can rearrange our operations and we can remap the bots and they're ready to go. So we were so focused on being able to put it into an existing operation. I don't think we focused enough on putting it into new operations as we brought on new customers. And really, I guess probably as much a communication problem or fault of mine as any. But I'm responsible for the back-end engineering, so I was really focused on that. I didn't care what the new design guys were doing, but
Right.
Really focusing on that and what does it look like to optimize a layout for these things. They're so flexible, they can operate in an existing operation, but is there a best way to lay out, whether we're picking from shelving or carton flow or whatever, is there a best way to lay that out to optimize the operation of the bots? So we're really focusing on that now, and in addition to other functionality out of our WMS that we're writing into the interface as well. So.
Mm-hmm. Yeah. I'm going to start with Joe, and the question, I guess, would be, this is a technology that has advanced pretty quickly, but you must be thinking about how to advance it even further.
Yeah. So
Yeah.
I think that, that's the whole idea behind building the solution as a platform. That is the foundation of what we're going to be doing moving forward. But, if you think about it right now, most folks think of this technology in terms of helping out with material handling. And even more specifically fulfillment. So we feel like there are a lot of places where some level of automated movement is going to be helping out outside of just maybe picking. And so I feel like with the breadth of platform, we're setting ourselves up for that. I think that with Tag Surveyor, you're looking at automated movement and workflows associated with collecting data. And then when you look at, all of these autonomous mobile robots, you're essentially looking at, a number of devices within your facility that, are sensor arrays essentially. And so the ability to hopefully be able to collect data and return that back to the users in a way that, they can use to do whatever it is, optimization, analytics, whatever they want. That's going to be critical to how we move this forward. And I think that we've got a cloud-based approach to how we do things. The ability to then aggregate that data across a campus, a large campus with multiple buildings or different regions. Those are all things that I think are coming up for us. And then on the research side of our business, we've been selling a mobile manipulator. It's essentially an autonomous mobile robot with a 7-degree arm. We've been selling that into research institutes, corporate innovation centers for the last 3 years. And so we're working on various commercial applications that might be good for as well. And so I think that there are just so many different things that, again, we feel like we've built that platform. It tends to be the gift and the curse to kind of go back to what Alan mentioned, is that there's enough flexibility where, there are a number of things that you could do with this. It's just, we're going through that process of figuring that out for, brand new installments as an example. So.
Yeah. And Bruce?
So we're continuing to, this is Locus, but then we're also doing some innovation at Quiet. So at Locus, obviously just making a better, faster, cheaper robot, which is a combination of the world we live in where the component prices keep getting lower, keep going lower through competition and innovation. But there's also just more capability within these sensors. So there's just more we can do with them. One of the things that we've kind of figured out quickly was that this is a software problem, not a hardware problem. And so we're spending a lot of time on optimization and software enhancements. I'd say we're just in the first inning of the optimization problem. It's just amazing the number of places we can run optimization. And we've only just scratched the surface of that. And that gets into cool things like AI and machine learning and big data and stuff like that. Then we're changing, or I guess optimizing around the size and shape of the robot. We're adding other use cases. Joe mentioned it too. There's just so many places you can put these robots beyond just a warehouse. But within the warehouse, we're also adding more and more tasks. The robot is a very good task executor, so we're continuing to add tasks that are currently mostly people-intensive tasks, and we're empowering those people with more robots. And one of the things we're pretty religious about is something that is known in the industry as Moravec's paradox, which is that robots and computers are good at doing things that humans are not good at doing, and vice versa. So one of the things that I think everybody who's not in the business should, read about if you get the opportunity is to understand it's not a direct line that says because a computer can beat Gary Kasparov at chess that it's going to then take over the world, because that's just a different kind of problem. There are so many things about what humans do that we don't understand and can't describe in a way that a computer can do them, that it's just not a good use of our time to try to make computers do those things. So we're very religious about trying to draw that line and make sure that we keep on the right side of it. On the other side of optimization too, and one of the exciting things that we're doing at Quiet is that we have, as Geodis has learned, that the building can actually change to make the robots more productive. And so we're doing a lot of optimization around how we design and build warehouses. And so Quiet was just acquired by another company. So these two firms, Locus and Quiet, were separated. And our new buyers are interested in pursuing a strategy where we're going to literally optimize the building and the location and the shape of the building itself. So when you get into kind of thinking about this, it's just the world is turned upside down now. We spent all these years optimizing for distributing product on the store shelves, and now we're trying to optimize distributing a product to your doorstep. And it doesn't make sense that, if people's expectations are that they want this thing delivered to their doorstep, that the best way to do that would be through a big building in the middle of Indiana. So we're thinking about this, on a whole different level.
You have a lot of buildings in Indiana, Alan.
Yeah, aren't you from Indiana?
I am, yes.
Yeah.
I hate hearing that.
There used to be
but-
cornfields there. Now there's just rooftops.
So tell me about that. I'm interested in this. I know it's early innings, right? But what does a warehouse of the future look like when you've optimized the warehouse for e-fulfillment, more of them smaller, more in the city environment, but physically, what does it look like that's different?
You asking me that?
Yes.
Well, obviously, if I knew the answer to that, I'd be a lot wealthier than I am now.
Yeah.
I can take a guess. If you look on the web and you Google Amazon warehouses, you'll see something very similar across all of them, which is that they tend to use the bottom 10 feet of the warehouse, and then there's about 20 or 30 empty feet above. And the reason for that is because Amazon is in the business of fulfilling individual orders, and they need people to do that picking. And I think it's a longer time than anybody else does that before a human can actually do that. I mean, a robot can actually do that picking for the reasons I mentioned earlier. So the question then is, if you have to use the floor, at what point does the cost of the building get to be so high that you now have to go vertical? Because obviously everybody that's ever walked into one of my warehouses, and we host MIT students and Harvard Business School students like monthly. So many, and the first question they all ask is, why do you only use the first floor of the building? And the answer is because it's cheaper. It's simple. But if I wanted to actually get close to the consumer and deliver something like they want it tomorrow or today, I can't get cheap land. In fact, I have to pay a lot. In New York City, it might be $10 million an acre. So how do you do that? Well, the question is, how do you go up? So in my view, I had this vision one day back in the Kiva days of, well, why don't we create a big, huge skyscraper in the middle of New York and just fill it with products? And it would be the biggest vending machine you could ever imagine. And you could just, right on the retail floor, you could just have like a little ATM type of thing and say, I want this product, and it would, ping pong down and shuffle, and all of a sudden there it is, boom. And that was this vision I had. So obviously you can't do that because it costs $2 billion to build a skyscraper in New York. But the vision is still the same, which is that's what people are headed for, right? That kind of immediacy where you can have anything you want, wherever you want it immediately. So that's the point on the horizon that we're headed for. So how do we do that? Well, the answer is we do figure out ways to stuff more product into a square foot of land. We get closer to the consumer. We use more automation, and I think the robots are a perfect example of that. And we try to store as many products as we can and make them as easy as possible to pick, pack, and ship and deliver. So that's kind of the vision we have. I mean, it's we're not going to have a $2 billion skyscraper in Manhattan, but it might look a little bit like that.
Yeah, and Alan, have you guys, I mean, you're starting to play with these ideas too, right?
Absolutely. And Bruce mentioned Amazon. That's almost a four-letter word, right? They have changed the expectation so much. We're not talking about final mile delivery now. It's really final meter delivery. And how do we do that? And I think that I actually saw a study not too long ago. It said, this was the author's words, not mine, but within 5 years, 100% of picks are going to be automated in some fashion. So if you think that this technology is not on the move, it is. But in addition to that, I think there's some technology around using the data, using some intelligence around what we put where in terms of products, really, and helping people with their networks. And based on buying patterns, knowing what we need to put in New York so we don't have to build a skyscraper. Maybe it's only 10 stories, but to help with that as well. But yeah, that's absolutely a problem we're looking at. And fortunately or unfortunately, a lot of distribution centers aren't in the center of New York for obvious reasons. They're usually somewhere where the cost of real estate and labor is a little less expensive. So
Yeah.
Like Indiana.
yeah.
Like Indiana?
Yes.
Yeah. The other thing that sort of has been raised, Joe, you guys are working with a robotic arm, and right now, and maybe it's not a full robotic arm, right? It's, what is it, suction cups or?
Well, it's got a grasper on it that's interchangeable with any
Yeah.
other type of device that picks up, and it's a 7-degree arm, so that it basically can get to pretty much any location right now. But yeah, I mean, when you're dealing in mixed inventory type situations or mixed asset type situations, there are a lot of variables to that problem, and so in our view, and again, being one of the leading providers to a lot of research institutes, very large research institutes around this, we're still a little ways away from being able to deal with hybrid inventory types with something like that. I think that there are solutions when you have potentially a more homogeneous type of inventory or asset that you're dealing with that maybe are capable of doing that picking, if you will, but that picking process, that part of the picking process. But once you get into that truly mixed environment where an arm has to deal with all sorts of different things in terms of approach angles and departure angles for the arm as well, it becomes a much more complicated problem. And I think that there are easier problems to tackle with that sort of solution, and those are the things that we're going to be focused on.
So what does a robotic arm cost? If you wanted to slap an arm on a robot, what are we talking about the additional costs there?
Yeah, so our mobile manipulator right now is $100,000.
Right, and your robots are 30 to 50,000, right? Hardware.
The small robots are in that range. I think
Right.
everybody's in the same general range.
Right.
And the larger robots, obviously, a little bit more expensive than that. But,
Right.
But yeah.
Okay. Bruce, do you have any thoughts on sort of the robotic arm on robots?
Yeah. So my view is that it's a really, really hard problem, and that it'll be solved incrementally. The edge cases are what really are hard. They're what kill you. So I think initially the goods to man systems will have an advantage because you can have a stationary arm that's powered separately, and you don't have to worry about weight and center of gravity and all those challenges. You know where that robotic arm is because it's bolted to the floor. And companies like Kiva and Gray Orange will actually bring a shelf full of product to that arm. And I think we'll see some strides there, but when you actually do the math on it, we can't figure out how that is profitable. Even if you could do it 100% of the time, we don't see that the pick rates will ever be fast enough to justify the cost. So those arms are still going to have to come down in price quite a lot. Once that problem's solved, then we'll think about mounting them on robots. But the problem with mounting them on robots is that, contrary to popular belief, the robot actually doesn't know where it is. It's very similar to like rockets, right? When a rocket's on a launching pad, it knows where it is. But when it's 1 inch off the launching pad, it doesn't know where it is. And the way we figure out where it is something, we call it rocket science, but it's basically mathematics. And we use all sorts of, advanced Bayesian inference and all sorts of filters, that will look at these guesses and then filter out the wrong answers and hopefully get enough right answers that you can get a good average answer. And it actually works. I mean, that's the way ships navigate the ocean, same way. So if you're dealing with that, you have some level of inaccuracy, and then but the robotic arm has to be very accurate to be able to pick something up, much more accurate than our autonomous mobile robots, which really only know where they are within a sort of 5 to 10 inch window. So you add that complexity to it too, and the whole thing starts to become, to me, one of the really hard problems that we're trying to solve in the world of science, just like self-driving car. I think everybody's super optimistic about self-driving cars. I'm not. And the reason I'm not is for the same reason, which is that the edge cases, there's so many things that just make it hard. And people are going to find that out when they finally get past the easy part. And we're just getting past the easy part now. But when you start to actually put a car on a road and have to deal with all the obstacles and all the things that are happening in the real world, things like rain and snow and fog, you'll all of a sudden realize that this thing isn't going to work. So don't invest in those. That's my advice.
So we've got 15 minutes left. I want to make sure the audience has time to ask any questions they'd like to ask. I can keep asking questions all day long. We got a mic coming up, so we're trying to get this on the video. Okay.
Thank you. I am Ani from Tata Consultancy Services. So my question is that the robos, the mobile robos, autonomous mobile robos, are they just for the distribution companies, or have you also tried them in manufacturing environments where there is a lot of need for replacing repetitive human tasks with collaborative robots? So how do you see your product fitting into the manufacturing environment?
Yeah, well, that's essentially what you guys are running. What Tyler's running is a manufacturing operation. And so, yeah, I mean, we definitely see, the technology as being very horizontal across a lot of different applications. And manufacturing is absolutely one of them in terms of being able to, move sub-assemblies to do, packaging material collection at the end of a line, and with Tag Surveyor to be able at some point to do some level of QA on material prior to the material making it to the line, or to track finished goods. There are a lot of different applications that are, already in play in the case of Tyler's facility, that are not just about a distribution or, general warehouse type thing. So, yeah.
Well, thank you. I'd love to connect with you.
Sure.
Hi, Eric from Sumitomo. You mentioned that software is probably the biggest hurdle coming up. What do you see as some hardware hurdles that may not be as big as software, but you still have to overcome them?
Yeah, as far as hardware hurdles, I would, I would say that, we have strong technology around the underlying bases, which, are essentially small self-driving cars. It's just that within a warehouse environment, you're dealing in semi-structured environments where, you aren't dealing with things like weather or small kids or pets. Hopefully they're not in warehouses. But yeah. And so at the same time, I think that, especially with the larger bots, that are capable of moving 3,000 plus pounds, it's more than, it's more than an emotional reaction that you'll get if that runs into you. So I think that those things we're still going through, and figuring out the accessory tops and ensuring really that those things are going to work. They're going to be repeatable, that it'll be industrial grade and will survive thousands, if not tens of thousands of cycles. Those are some of the things that I'm thinking about from a hardware perspective, at least.
So it's a size scale?
Yeah, I mean, that is a part of it. I think that when we go through and we're looking at, how the industry is developing its safety standards, as an example. And so we're an active participant in that process because these are new technologies. I would say that those are the things that we're keeping a very close eye on. And so it's something that, obviously we take it very seriously, and it'll come down to really the big robots themselves, making sure that they're completely buttoned up, in terms of just the types of accessories that'll go on top of it. And so I think the accessory piece is the piece that that very specifically needs to be addressed a little bit more, in a little bit greater detail. And I think what you see is a lot of solutions out there that are stitched together, and that's just not the way that we're doing it.
So would it be more impactful to be more compact, where a smaller robot can lift 3,000 plus pounds, and that makes it easier for you? Or you mean it's kind of the load that it's carrying that's the important part?
It's the load itself that it's carrying. It's not the underlying base. So just, I don't know if that was clear. It's the accessories that go on top of it, and the ability to, detect obstacles above and below those accessories, as an example. Those are the things that become tougher problems to deal with as you scale things up.
So I could jump in a little bit about, I can't say what, well, I'll say what I can say. We would like better sensors. So right now, the sensor we use is a planar, single plane, and it sees about a foot off the ground. And we would like multiplanar sensors so we could see above and below. That's our laser sensor. We have cameras that can see up and down, 3D time of flight cameras, but they can't see very far. So you have this trade-off. You have to have both. There's a little nuance about robots that people that want to supply a robotic company should realize is that even though we have multiple sensors, we have the LiDAR, which can see 30 feet, and we have the cameras that can see 3 feet. That's actually kind of okay, because when we do all this triangulation, more sensors is better, because what we're doing is combining the data from the two sensors, and then we have essentially more inputs into our algorithms. And so even if we could maybe get that all in one sensor, we still might have to have two sensors and located in different places. So, and then the obvious stuff, faster Wi-Fi is huge for us because we're passing so much data around. We do, I think it's like 10 hertz or in some sensors, and it's 40 hertz in other sensors. And so every sort of few minutes, you're generating huge amounts of data. And then we're sharing that data with the database and between the robots. And so the more Wi-Fi coverage you have and the faster that is. And people may say, well, what about 5G? Well, we like 5G, but I don't think 5G works very well around steel racking. So we might not be able to use it. And then bigger buses for moving data inside the machine, and then faster chips. And all those things sort of seem like they're obvious because they're going to happen anyway. But the implications from our perspective are huge, because we're generating, terabytes of data every day for every robot. And a lot of it's just junk, a lot of it's noise, and we discard most of it. But if we can use that data to our benefit, that helps everybody. But then we need a lot of power on the unit to be able to do that. And then there's batteries. The bane of every roboticist is batteries. We seem to have sort of reached a point where we've eked out as much power as we can. We have in our robot, we use a lithium iron phosphate, which is a type of battery that's very safe, but it's not as powerful as some of the other lithium-ion batteries, which aren't as safe. And there seems to be this trade-off between power and safety. And so what we really want is a super powerful, super safe battery. Got that?
Yeah. And it's interesting because all of those hardware-related things that were covered, I mean, it does route back to software in a lot of cases, and I think that again ends up sort of really being the key issue.
Any more questions? Well, thank you very much for coming.